Okay, so for the next 4 class meetings, I'll be doing nothing except going through a MATLAB tutorial. So this corresponds to section 1.2 in the text, but it's the MATLAB tutorial. I'll basically be stepping through that, but we're making it to be aside, especially based on any questions that you all ask. What I will post in Canvas and on my site after each class is what's called a diary file. So it's a text file that has all the commands that I typed in during the class and any output that was generated. Okay, so this is the time for y'all to get familiar with MATLAB. I know a number of you have your laptops here. If you are able to try to follow along and try things, that's great, but if not, you can always do it later because this will also be recorded. So the first homework assignment is consistent explorations from the MATLAB tutorial. Once y'all get through that, and after this tutorial is over, the first homework will be due a week past that point. And certainly MATLAB is one aspect of the class that students have the most trouble with. So hopefully we can get everybody. The very first thing I'm going to do, as I mentioned, is get a diary going. That's using the diary command. Now, if you just use diary by user interface that we have here, yours might look a little different because I made some changes in my own user interface because some of the things that aspects of MATLAB layout drive me nuts. Okay, so what you see here is called the command window, as you can see right here. The double greater than sign, so that's the command prompt. So I'm starting to type my first command here. Over to the left, we see all the files that are in this directory right here. So up top, you can see what this is the directory that I'm in. So by default, it's going to be something like under your documents folder, which will vary depending whether you're on Windows or Mac, /MATLAB, and then I've created subfolders under that to put all my tutorial files in one place. This part workspace has variables. Right now I don't have any variables, but soon I will, and I'll point those out down here. Here is this command history. That might not appear for you by default, but it's something I like to have because I can go back and find my previous commands and rerun them. So I should mention this one here, this command, soda main. I don't know if you've ever seen this, like maybe in ads for various phone games and so forth, where you're trying to get soda bottles to all have the same colors, the right colors in them. Yeah. So I wrote a MATLAB program that would solve it for me. So maybe sometime I can demonstrate that. And I have other fun MATLAB demonstrations that I'll do for you all later. But first, the boring nitty gritty. Okay, now, if you look at the files that I have here, we'll be dealing with some of these later on. So the .m files, that's where MATLAB code goes. They're ordinary text files. You can view them in any text editor, but MATLAB has its own editor. Right now, but we'll see that later. And then there's just some ordinary text files. Now, when you work out problems involving MATLAB, if you do have code sorted files, .m files, well, these are among the things that you should submit. What I also want you to submit is what I'm about to create now, a diary file showing what you did in your MATLAB session. Now, these are also ordinary text files. You can edit them in any text editor. So if you try some things in your MATLAB session and certain things go wrong, and then you figure out the right thing, you don't have to send me all of that. You can edit it first and clean up the crap. which I will do with this diary. If I mess something up, I'm gonna edit that up. So, also you can put in your own on commentary about to help me understand what you did. So the very first command I'm going to use, diary command. If you just do diary by itself, it will save everything you do in a file that's just called diary. I don't like that because then you try to open it like in a text editor, and it's like, I don't know what to do with this because there's no extension. So I'm going to give this file a name. So if I specify tutorial today's date .txt, I'm giving it a .txt extension so that I can open it in a text editor later. So once I hit enter, you'll see it's created the file up here. I've sorted by most recent recently modified files, which is why it appears at the top in this case. So now, right now, there's nothing in this file, but as I start typing commands and generating output, that'll be saved to that file. Now, what I'm trying to remember to do as I go through this, is notice the text here is now green. This percent sign is for comments. Pretty much all programming languages have some way of including comments in your code. So for instance, like in C++, you can do like a double slash to comment on the rest of the line. So once I type a percent sign, everything to the end of the line will be ignored as far as Matlab syntax is concerned. So I can type whatever I want, whatever commentary. So all subsequent commands and output will be written to diary file. Okay. So I can start by just showing you very basic mathematical operations. In fact, sometimes I just use Matlab for a calculator because I always have it open anyway. So if I do something very primitive, so just performing ordinary mathematical operations, and I'm taking between 3 plus 4 and I'm assigning that to A. So just like in any other programming language, the equals is used for assignment of a value. So whatever expression you have on the right side is assigned to a variable on the left side. And notice it prints out results, so A is equal to 7. Also, you see down here in the workspace, before it was empty, now we have something. We have a variable A, and it will show its value over here, the second column, 7. Basic mathematical functions are available. For example, do B equals square root of A. Then I'll go ahead and compute square root. It's square root of 7, so that's going to be an irrational number. And so now that's listed here too. But we're not seeing many decimal places. It's only displaying 4 digits past the decimal point. That's the default. It's called the short format. I can change that. So by default, format short. That's 4 decimal places. But now what I'm going to do is format command, and the argument will be long. Okay, so now I can perform another operation. So exp is the exponential function. So computing e to the a. So it's the natural exponential function. I'm going to comment that. Okay. And now we see a lot more decimal places. 15 decimal places in that case. Also notice it uses scientific notation. So really this is 1096.633 blah, blah, blah. Okay. Now, common mistake, multiplication needs to be specified explicitly using the asterisk. So I could do 2 times A, for instance. It's not smart enough to understand that this means 2 times B. So a lot of times students forget the asterisk because on paper they wouldn't need it. So it's complaining. Balance better used to be about trying to figure out what you were trying to do and make a suggestion about. So here it's saying, did you mean D equals 2 times B? Okay. In this case, yes, I did. We also have exponentiation. B was earlier computed to be the square root of A. So if I go ahead, and A is 7. So if I go ahead and square that, I should get 7 again. But watch what happens. It's close to 7, but not exactly. That's because there's round off error. Now that's something we're going to see a lot more of later when we get to chapter 2. So that's something to be aware of, that there is limited precision. So you take square root of something and you square it, you're not going to get exactly the same thing back, but pretty close. Different languages have different character sequences for exponentiation. Some use up arrow or caret. Others use like Fortran uses a double asterisk. So here it's the caret. All right. So far I've just done everything with scalars, but Matlab, the name comes from Matrix Laboratory. In fact, how Matlab got started was actually it happened at Stanford. Way back, I think probably late 70s or early 80s or so, my advisor, you normally teach the numerical linear algebra class, but one year he was away on sabbatical, so it was taught by another professor, another institution. I forget where exactly, but his name is Cleve Muller, filling in for Gene, and he wanted to have some way for students in this class to work with vectors and matrices in a more hands-on way. And then when you take a linear algebra class like Math 326, if you're doing it on paper, you can't really work with large matrices that way. It's terribly impractical. And numerical linear algebra is about larger scale problems. So he created what would become Matlab for students to do that. So it wasn't created by a Stanford person, but it was started at Stanford, and then he went off and left academia to start the MathWorks as a company, and it all took off from there. So I'm going to show you what to do regarding matrices. So I'm going to switch to showing you the most basic operations involving matrices. For example, how to create a matrix. So simplest way is by typing in entry by entry. Now, notice the okay, we're creating a 2 by 2 matrix A. So notice the entries are specified one row at a time. First row, and then semicolon. So rows are ended by a semicolon, and then entries within a row are separated by, here I use a comma or space. So the commas were not absolutely necessary. If I left the commas out but had some space in between, it would have done the same thing. I would recommend commas to separate entries within a row because space can be ambiguous. It just tries to figure out what you meant. All right, now create another 2 by 2 matrix. So here I won't use the comma, so the equivalent syntax. Okay. And now I can go ahead and form matrix arithmetic. So if I go ahead and do A plus B, right, so it goes ahead and it does exactly what we expected it would do. It's entry-wise addition. Now, one thing is worth pointing out here. Notice I just did A plus B without assigning it to anything. I didn't do something like C equals A plus B. I just did A plus B. And now we have this variable called ANS, which is short for answer. Okay. So it's the last unsigned result. And you can see it in your list of variables that is stored there. So you could treat it like any other variable if you wanted to. I could do this, for example. I could take 2 times ANS. So it will take this matrix and multiply it by 2. But look what it did. It carried out the operation. But now that is assigned to ANS. Like I said, ANS is always equal to the last or most recent unassigned result. So, if you're gonna do things with it, and sometimes I do it just because I'm lazy, it keeps getting overwritten. Whereas if I had said like x equals 2 times ANS would still be equal to this, and this would be assigned to x. So ANS, that's why I emphasize ANS is always the last unassigned result. Questions so far? So, what?
Do you have to be consistent with like the spaces and commas?
Oh, like here where you're defining a matrix?
Yes.
No. Well, you have to have the same number of elements per row, just so yeah. But as far as like how, no. All right, so now that A plus B I did earlier, I no longer have that because ANS got overwritten. So I'm going to go ahead and repeat the operation, but this time I'll assign the result to a matrix C. So I have that sum. Okay. I can do scalar multiplication. So 4 times A, we'll do what's expected. Okay. I can also addition, subtraction all work as you think. Here I have a matrix multiplication. The A and B are both 2 by 2 matrices, so certainly multiplying them makes sense. But now suppose I create a column vector. This is how you create a column vector. A column vector is really just a matrix that only has one column or one element per row. So you separate them by semicolons. If I did not have the semicolons in here, I would have a row vector. Now, A is a 2 by 2 matrix, as you can see here. W is a vector of length 3. So if I do A times W, that is an operation that does not mathematically make sense. And Matlab is happy to tell me that in many words. This is something worth pointing out. So there's two multiplication operations. So there's star that is used that performs whatever matrix multiplication you want, as long as the operation is well defined. But there's also dot star. Dot for an arithmetic operator is used for component-wise operations. For example, suppose you have 2 matrices that are both 5 by 3. It doesn't make sense to multiply those matrices. It doesn't follow the rules of matrix multiplication. But, so if I have 2 matrices, A and B, that are 5 by 3, I cannot do A times B. I could do A dot star B, which would give me another 5 by 3 matrix from multiplying corresponding entry, so component-wise multiplication. It's also known as a Hadamard product. If you have two column vectors, you can't multiply those without transposing one of them. But you can do component-wise multiply with dot star, and so sometimes that is convenient to do. Like if you want to take a matrix and okay, so if I have this vector w here, it won't let me do this. Exponentiation using the up arrow only makes sense for scalars or square matrices. If I really want to square these elements individually, use dot up arrow. So I can do dot squared. Okay, so multiplication, division, exponentiation, operations that are not normally applied in a component-wise manner. If you put a dot before it, it will carry that out component-wise. It's not needed for plus or minus because those operations are component-wise already. All right. Now, I'm going to show you one aspect of Matlab that personally I object to, but you need to be aware of it. So I'm going to create a row vector now, Z. So I have no semicolons. So this is a matrix with 1 row, 3 columns, a row vector. Now, W, to recall, is a column vector. So you might think if I'm going to do W minus Z, you might be thinking, well, that operation doesn't make sense. That if you're going to add or subtract matrices, they have to be exactly the same dimensions. But Matlab will do it anyway. And I really, really hate that Matlab does this. This kind of operation used to be an error. So what exactly does this operation mean? So if you are subtracting like a row vector, column vector, what it will do is it'll give you a matrix that consists of all possible, since I'm subtracting, all possible differences. So it's a matrix of where the ij entry is wi minus zj. So for instance, the first column is the vector w minus the first element of z, which is 1. So 4, 5, 6, now 3, 4, 5. Second column is taking w and subtracting the second element of z, which is 2. Then the third column is taking vector w and subtracting the third element of z, which is 3. Now, that's actually a useful operation for constructing, for example, what are called distance matrices. If you have a whole collection of points and you want all possible distances between them, this kind of operation is very convenient for doing that. The reason why I personally object to this kind of operation is sometimes this can obscure coding errors because if this is what you really want, then great, it's convenient. But I've had cases where, like, if I'm looking at a student's code, and what they meant to do was subtract 2 column vectors, and then when they come to me, their code's not working, and it really can't figure out why, getting these crazy results. And we find out that in one case they created a column vector, and the other vector was a row vector, and you didn't realize it. You got things all transposed, and then it did something like this. And we had no idea because there was never any error message generated that indicated something was wrong. So I'm kind of mad at them about this. But it was just a few years ago where we started doing things this way. And I get it, but like, no. So something to be aware of. I'll just make a comment here. Scroll computing. This is probably something Google. Distance matrices. So by now we have a fair number of variables here. So I'm going to type this command, get even more information about them. It's so if I just do who, it just lists the variable names. It doesn't tell me very much. But if I want more information, I can type whose. And so all variable names, what size they are, the matrix of rows by columns, how much storage each takes up, and the type. Now everything we've done here is numeric, so these are double precision floating point numbers. So for example, this matrix A here, 2 by 2, so there's 4 entries in total. Each double precision floating point number is 8 bytes, so we have 32 bytes in total. So we have a who command. There's also a what command. That just lists whatever code files I have in this directory. Oh, okay, there's a where command, but I don't have Simulink installed. I have no idea what this does. Okay, there's no when. There's no how. Here's a why command. It makes up a random reason. Yeah, the bald is not excessively bald, so it's complicated. And not excessively smart hamster would be a bit terrified, and not excessively terrified hamster. If I keep doing this, it'll keep generating. Yeah.
When we typed in where, it said, did you mean wheels as well?
Mean what?
Wheel?
Wheel?
Yeah, like a tire wheel?
Oh, okay. Interesting. There is a which command.
Still having that trouble.
Oh, it didn't not install.
I think so.
Okay, I'll have to wait till after class to check it. Yeah, so it'll just keep so when you're frustrated, you want to know why your code's not working, you can type this and it will tell you. Okay. Borrow this.
So every time you do Y's.
Yeah. Yeah, using a random number generator to concoct a phrase. This is always the first one, it's a really long one. Okay. Now, everything we've seen so far is real numbers. We can also do complex numbers. So I can create a vector. So now there's a column vector where the first element is still a real number, so 6 plus 0i with no imaginary part. Then we have 3 plus 4i. Let me go back to the format short here. Okay. We don't need 10 many digits for this. But now I'm going to do whos again. And we see, okay, we have 2 elements, but each one occupies 16 bytes. Why is that?
Well, because of the short,
No, this isn't.
what's your question?
Okay. Look, all these numbers up here are 8 bytes each, but these are 16. Just for Z. So how come Z requires double the storage per number?
Oh, real and imaginary.
Yes, real imaginary parts have to be stored separately. Yeah, format's only about display. Yeah, and so the way it's kind of wasteful. 6, the first element is a real number. The imaginary part is 0, but it's storing the imaginary part anyway. So if you have a matrix where even one element, one entry, is complex, it will store an imaginary part for all of them. So, and yeah, that might be wasteful. So a lot is done to avoid complex arithmetic, but now and then you do need it, so we have it. Now to extract the real imaginary parts, like if I do y is real of C, so it extracts the real parts of each element. And I can also do imag of Z to get the imaginary parts. and Y is real. Notice that Z has notation of complex, but if I do real or match, it'll just take the one part, half of it that is desired. Questions so far? Yes.
How do I get the MATLAB on the desktop?
So it did not already put it there?
No, it did not. No.
Okay, are you you're in Windows, right? As opposed to a Mac?
Yeah, I'm in Windows.
Yeah, so what you could do is you can create a desktop shortcut to MATLAB. But even then, I guess you can always run it from the start button anyway.
I made a folder for mine and then just like looked up Matlab and then moved the folder that had the diary into it.
Okay.
You could also store it in your OneDrive.
I don't know what to do.
I can take a brief moment to take a look, but I have to make sure to get through all the tutorial stuff.
What all I got so far.
Okay. Oh, so now it's running.
It's not on the desktop.
Okay. That's the old version.
Yeah, that's the old.
Okay. Let's try this. Right click. Let's see. Go scroll down to new.
Lazy? Are you lazy?
And then shortcut. Okay. Go to browse. Go to. Oh wait. Scroll down a bit. Oh, that's the old MATLAB.
The tablet versions are more condensed, or they can't handle having all of this stuff.
That makes
But it stores it the same.
Did you log into?
Oh, go to this.
I kept typing Y and it wrong, like it was getting not at.
But that's the installation.
Mine didn't, mine was just like,
Yeah,
mine.
Sleep.
There was just that there, but I kept going.
Go to
Well, it has like a random generator.
program files.
Well,
MATLAB.
my.
Yeah, mine was following.
And then I kept hitting Y and then.
Free.
So eventually it starts getting
And
around.
then scroll down.
Didn't need it, don't need.
Oh,
As a kid, ask him why. Did you get into it? That's not why.
Just like a dad. Yeah.
Go to bin.
I don't get this stuff though.
Scroll down.
The hamster, I don't know.
Oh, MATLAB.
Must be inside.
One, two. That's what we want. That's the actual MATLAB. Oh, okay. Okay, next.
Petition. It's cheaper.
Okay, and then, so there's no, give it a different name.
Match the other one.
It's the same thing with business.
Where'd you go?
I feel like.
Hattiesburg tattoo, they were doing like a $40.
I feel like they're really funny.
Wow. And it was just, I was like, I was paying $80 for it.
Yeah.
It's expensive.
On a small area.
I feel like
I went.
You said
and I
who?
thought I was gonna get like the outline or something else. And he was like, I'm not gonna do it. I'm just
You already
gonna
got
until
it.
5.
Go ahead.
I got there at 4 and he said he was getting ready to leave.
Like, but also doing certain
Basically, change your hours, just don't ever stop before that. Yeah.
I'll give you no enough.
So he opened it, the words, and then I just let you room. So I'll give it back tomorrow.
We go back now.
Like, 80 numbers, or
Time for taking out
Joseph Rouse.
Sorry.
Okay,
Yes, sorry.
that's fine. Didn't take very long. Okay, now, so far we don't know much about how to create a matrix. I mean, if you want to create a matrix with specific numbers, you know how to do that. But here's some convenience functions for creating certain types of matrices that are often used. So if I want to create a matrix where every element is a one of a given size, that's the ones command. So here we have a matrix of, so the arguments, so ones m n creates m by n matrix, specifying rows and columns. Or, if you're feeling lazy, you want to type less, ones with only one argument creates n by n square matrix. Which I found the hard way. It's very different in a language like Julia, which is very similar to Matlab, where I do the same thing with create a vector, not a matrix. So anytime we want to have a matrix where all entries are the same element, ones is good for that. Like if you want a matrix of all twos, you can use a ones command and multiply the result by 2. Yeah, so for example, if I do ones 3, so that's a 3 by 3 matrix. What's even more useful, zeros commands. So a zero matrix that functions in the same way. Another one's useful often, rand. So here this gives me a random matrix. And the numbers are uniformly distributed in between the open interval 0 to 1. There are other functions that will generate random matrices using a different distribution. I think that rand n is for a normal distribution. Rand function is useful for what's known informally as a proof by Matlab. So if you can show that some result works on a randomly generated example in Matlab, then it must be true. And yes, I actually have published papers that feature a proof by Matlab. Now, it's not really accepted as a proof, of course, but it is at least evidence that something is true. But yeah, in the paper, I really did call it that, and basically find it. Okay. Now, so now, suppose I want to create a vector that has all the numbers from 1 to 10. Right? Now, we already know how to do this based on what I showed you earlier. So I can just do this 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, so there's my row vector. Now, suppose we want to do the same thing, except I want to double numbers from 1 to 1,000. I would not want to type all that, but you don't have to. Here's a shortcut. Colon operator is for specifying ranges. So z1 colon 10 will give me the same thing as just typing it all out. So a colon b is a row vector. I want to emphasize that. Consisting of a plus 1, a plus 2, etc. And then not, so it'll stop. It'll keep going as long as the elements are less than or equal to b. So it will not. So the elements effect will not surpass b. That's in case, like, for example, if I do 1 colon 3.5, so it'll give you 1, 2, 3. This won't go past that. But sometimes you don't want every single number from A to B. You might want to skip. Like, what if I want the odd numbers, 1 to 10? If I do 1 colon 2 colon 10, so it'll give me the odds starting from 1 in steps of 2, not exceeding 10. So, so A colon S colon B is a row vector that starts at A plus S, A plus 2S, and so on. not exceeding B. Okay. So you can use whatever spacing you like. Now, you can even use a negative spacing if you want to step backwards. I do 10 colon minus 2 colon 1. So in general, if I have a starting point A and then a negative spacing as the second argument, so that would give me A minus S, A minus 2 times S, as long as your elements are greater than or equal to B. Okay. Now, you have to be careful if you're going to step backwards, have your largest value first, because if I do this, 1 colon minus 2 colon 10, it'll give me nothing. Because based on this logic here, that if it starts with 1 is already less than the number here, so it would not include anything. So it is possible to have an empty matrix, that has no rows, no columns. So in fact, if I do whose again, yeah, Z has 1 row, no columns, no storage. Now, we've seen that every time I do something like this, it prints this out. Now imagine if I did something like this. I'm not going to do that. In fact, last time I taught this class, I did do this. It made the diary file large. And before this class, I had to take the time to strip it out. Yes?
Is that sheet gonna be published later today?
Yeah, this diary will be posted in Canvas. Yeah. I don't think I'll be using any code files today, but when I do, those will also be posted in Canvas. So I may want to do something like this, but I don't want it to print out. So I don't have to have it print out. I can instead use a semicolon. Use a semicolon at the end of the statement to suppress outputs. So there's a very different usage of semicolon from what you see in other languages. Like, what's the importance of a semicolon in, for example, C or C++?
Well, that's you're separating those to the declarator statement.
Yeah, you have to have it.
Yes.
Matlab is more line oriented. So that's why it can get by without requiring the semicolon. Now, both modes are useful. For example, if I'm developing code, so new code, I might want to have it print out things so I can check, it's easier to check if my code is working. And then once it is working, then I put semicolons in to kind of clean up the output. Yeah, C and C++ are totally free form when it comes to syntax. Your programming instructors may tell you to format your code a certain way just so they can read it. But there's actually a contest that's been running ever since I was an undergrad, in the 80s. The International Obfuscated C Code Contest. So you can Google that and find the winning entries. And they're pretty awful. Well, ingenious, but yikes. Okay, but at least none of this is Fortran. That's the worst one. Okay. Now, so you can also build matrices by adding on to existing matrices. So I'll start this 2x2 matrix. Okay. And then I'll make another one that's a 2 by 3. Okay. And then you get another one. That's 3 by 2. Okay, so make note of that, A is 2 by 2, B is 2 by 3, C is 3 by 2. Okay, so now what I can do is I can concatenate matrices horizontally. So A and B have the same number of rows but different columns. If I slap them together, I now have a 2 by 5 matrix. So here's A right here, first 2 columns, and then the remaining 3 columns come from B. I can also do vertical concatenation. So I can do A semicolon C. That's so it puts A on top of C. So as long as the 2 matrices in question have the same number of columns, you're allowed to do that. And if you try to do something that doesn't make sense, like if I did A, C with no semicolon, it wouldn't allow that and give me an error. I can also intentionally create an empty matrix and build it up. So here I have a set of square brackets with nothing in them. And then what I can do is tack on entries. So now I have the beginnings of vector. So I'm a 1, I'm a 2. So building a row vector. I can add on as many elements as I want at one time. Notice I don't have any semicolons. If I put semicolons in between everything, I could build up a column vector the same way. But I want to point out, while I do this sometimes in my code, it's quite convenient. Like if you have a loop going, and you want to have a matrix like rows for each iteration of a loop for whatever reason, that's where something like this can come up. But it's actually inefficient. It can slow your code down. The reason why is, if I do something like this, what it's going to do is, x at this point is a vector of length 2. It's going to deallocate this vector of length 2, allocate a new vector of length 5 to put all these in it. So if you have something like this going in a loop, it's going to do repeated deallocation and reallocation at a larger size. That kind of overhead wrecks your code's efficiency. And what you'll see is one of the things that Matlab will warn you about, like that saying, oh, you have a variable that's changing size every time through a loop. It's kind of a no-no. So what we recommend is using a command like zeros to pre-allocate this, and that speeds your code up quite a bit to do that. All right, so we have some idea about how to create various matrices. But what about working with individual entries? I haven't shown you anything about that. Oops. Or how to change entries. Okay, so here's our matrix A that we had before. So if I want to refer to an individual entry, I can do this. Use parentheses. So this gives you the entry row 1, column 2. Some languages use square brackets, but Matlab is parentheses. So sure enough, it gives me the 3 right here, row 1, column 2. I want to point out, Matlab uses what's called one-based indexing. So the first row or first column is that's index value 1, which makes sense because mathematically, if we're working matrices on paper, that's what we would have too. But I point this out because other languages like C, C++, Java, Python use zero-based indexing, whereas Matlab, Fortran, Julia use one-based indexing. I guess it's something that no one can agree on. Okay. Personally, I prefer one-based because it'd be easier to translate formulas from paper to code that way. Okay. Now, if I go ahead and create a random matrix, I don't have to access entries one at a time. I can do something like this. I can use ranges that I showed you before. For example, what this will do is it will access entries from row 1, and then this is columns 1, 2, and 3. So in other words, it's going to give me the entire first row. So 1, columns 1 through 3. That's what this expression did. I can go the other way. Rows 1 up to 2, and then column 1 will give me this entry and this entry. So you can use these ranges to access a portion of a row or column, or both. If I do this, A 1 colon 2, 1 colon 2, this will give me the upper left 2 by 2 block. Yeah, so these entries right here is what it gave me. Any questions so far about this kind of element access? There's some shortcuts. Like you want an entire row or column.
I have a question.
Yeah.
So is all this, are we gonna have to like sit and try to memorize this, or is this gonna just come through practice?
Well, I mean,
A mix of both?
you're not gonna see this on a test or anything. But I mean, through practice, you're just gonna remember it anyway. But yeah, I mean, you may in the beginning you might have to find yourself referring to examples and so forth to see, okay, how do you do this? Yeah. But as I said, when it comes to coding, it's all about the immersion. And again, it's all true of mathematics. So okay. All right. So this, if I have a colon by itself in the first index position, that refers as a shortcut for all rows, and then column 3, so that's the third column of A. Or I can do, if I have a colon by itself in the second position, this would give you the entire first row. Another shortcut. Suppose I want the last column, and I don't want to know or care how many columns there are. Use a special keyword end. So this would give me the entire last column, however many columns there are. And you can do arithmetic with it. Like for instance, instead of end, if I put end minus 1, that would be the second to last column. Here I can do, this is rows 2 bottom and column 1. So this will give me the entire first column except for the first entry. Now, when I introduced ranges, a colon operator earlier, you recall that it always produced a row vector. I can use any row vector I want as indices. So here's an example of that. If I do, this is rows 1 and 3, all columns. So then it'll just extract only those rows. Or if I do the opposite, don't need to have to be in order. So this is row 3, then row 2. No, that's wrong. This is something I'm going to edit out of the diary. Column 3, then column 2. Because I put all that in the second index position. And and I'm gonna put A back up here just so you can see. Right, see that, this right here, that's the third column, and second column opposite.
Scroll up this little bit.
Questions at this point? Fortunately, these same pages are not numbered. I lose track of them. I'm also getting close to the end. So. Sorry, I didn't take a second to look to make sure that. Double sided wasn't that bad either. Yep, put all that. Yeah, we are getting close to the end. That's good because we only have 15 minutes left. Okay, so if I create, I'm going to look at random matrix here, 5 by 5. Okay. Yeah, so I can do something like this. One more indexing example. 1, 4, 3, 5, 2. So this will take entries 5 and 2 of rows 1, 4, then 3. So you can see by comparing to the original B where the entries came from. So for example, here we took entries from row 1. Here's a 7058. Here's a 2940. So column 5 and column 2. Okay. Now, another fundamental matrix operation you learned about in linear algebra is transpose. Now, suppose I want, and sometimes I do want this, a range of values like 0.1, 0.2, 0.3, and so forth, or starting from 0 all the way to 1. Okay, so all the tenths. But I want the column vector, not a row vector. That's easy to do. I put a single quote, a single quote or apostrophe, and that will carry out the transpose of this vector in any other column vector. But you have to be careful about this. It's not always transpose. I'll show you what I mean. I'm going to make another vector. We saw this vector earlier, 6 and 3 plus 4i. This is complex. And now I'm going to take what appears to be a transpose. But how? Compare these entries, the first one, when I use the apostrophe, what happened?
3 minus 4.
Yeah, so 3 plus 4i here became 3 minus 4i here. When you negate the imaginary part like that, what are you doing to a complex number? What do we call that?
Conjugate.
Yes, it's a complex conjugate. So what I'll point out here is that operator, the single quote or apostrophe, is the Hermitian transpose. And what I mean by that is a transpose and complex conjugate. Okay. It's usually in mathematical writing, it's often denoted by wherever the capital T is used, the superscript is used for transpose, the capital H superscript is used for Hermitian transpose. Maybe not every book does this, but a lot of books do. Okay, so how do you do just a plain old transpose? If all you want to do is make sure to reverse the sense of rows and columns, no conjugation, whatever vector is really complex, do just transpose, use dot quote. So if I do z dot quote, then it would not conjugate. it seems weird for the default to be conjugation, but the reason for that is if you have something works for real vectors and matrices that involves transpose, and you want to generalize that to a complex case, almost always you're going to want the Hermitian transpose. So that's why that is the default. So here I have, here it's a real matrix, so you can use either one, it'll have the same effect. Here's just reversing sense row of the column, just complication is moved. This also has a function, transpose of A does the same thing, but obviously it's nice to have this shorthand. Now, so as I mentioned, like if I do z equals 2 plus 5i, so then z transpose will just give you a complex conjugate. Some of this conj of z has the same effect. Okay. So I have a ton more to show you, but I also have left for you to what to do it. And I've reached the end of today's diary. But yeah, we'll just see a lot more. But also, because there's time, I can see if anybody has any questions.
Does this automatically save after we created it at the beginning?
Well, I'll take you to my next point, actually. So I have this diary that I've been generating, which I want to post later. And if I do diary off, then this is stop logging. Now, if I just quit MATLAB, that will have the same effect.
Okay.
Also, if you have a diary file going, if you quit MATLAB and you come back and you do diary again with the same file, it will append. It won't destroy what was already there. But I can have different diary files for each day with different dates. Otherwise, that would be a massive file. Okay, now, so now you have a file, like, if this is what you did in your MATLAB session with whatever code you're doing, then that's something that you can clean up and turn in. Okay, now, if I look at the diary file, okay, so that's this one right here. If I double click on it, it will launch a MATLAB editor. We're going to see a lot more of the editor later. Now, one thing I don't like about the diary file is it doesn't show me which are command and which are output, because here in the command window, you see this nice prompt here that makes it easy to distinguish command from output. And what I might do, actually, I think what I will do is I can just go ahead and copy all of this. Well, that's going to be a lot, but and so then it's like formatted in a more readable way in case y'all want to look at this later. So yeah, so you can always copy and paste your output from a command window.
Copy and paste the entire thing.
Yeah. Oh, let's see. Yes. Now let's see. It'll only go back so far. Okay. In this case, I got everything because I didn't have too much output. Now, if I had actually printed a 500 by 500 matrix over here, then I would not have been able to go back all the way to the beginning. So yeah, I actually think I will do this. Then go ahead and copy that, and so I'll just paste this into an empty text file for later. Okay, so what I will do is if you look in